Good morning. Today we are going to talk about trapezoids and kites and characteristics of them. So, first of all, let's go ahead and define what a trapezoid is. A trapezoid, by definition, is just a quadrilateral with exactly one pair of parallel sides. If you recall in the past, a trapezoid can look like this with your one pair of parallel sides, or it can look something like this. Oops, my pen's not looking too cool, but there you go. It can look something like this. Sometimes there's a right angle here, but it just has one pair of parallel sides, unlike my parallelogram, which has two pair of parallel sides. With the trapezoid, there's a couple characteristics we need to talk about. First of all, we have the base of our trapezoid. The base of the trapezoid is the parallel sides of the trapezoid. So if I'm looking, I'm just going to draw a trapezoid right here. So right here, if these are my parallel sides, this is my base and this is my base. It has two bases. If you recall from the formula for area of it back in elementary and early middle school, the formula said area equals 1/2 height times base 1 plus base 2. That's because it has two bases and they are the parallel sides. Then we have our base angles of our trapezoid. The base angles of our trapezoid is the trapezoid has two pairs of base angles. Each pair shares a base as with a side. So first of all, down here are base angles that share with the base down here. Up here are base angles that share with the top. At this moment in time, nothing is congruent. Nothing. With a regular old trapezoid, nothing is congruent. So it has two pairs of base angles. And the base angles fall around the base which it's near. Then we talk about the legs of a trapezoid. The legs are my non-parallel side. So this side here is going to be a leg, and this side over here is going to be a leg. Then we talk about our friend isosceles trapezoid. He is the trapezoid that we're going to focus on more so than anyone else because he's the one that creates all properties. Mr. Little Trapezoid by himself only has one pair of parallel lines. That's it. But when he becomes an isosceles trapezoid, now that's where my theorems occur because all these properties start occurring. So an isosceles trapezoid is a trapezoid in which the legs are congruent. So when I have my little trapezoid here, and I have my base here and my base here, on an isosceles trapezoid, my legs are congruent. Now, you're going to see, because my legs are congruent, just like in an isosceles triangle, my base angles become congruent. You're going to see all that stuff start happening. That's all my theorems. With that as well, if you recall back when we did triangles, we had a mid-segment of a triangle. Well, now we have a mid-segment of a trapezoid. The mid-segment of a trapezoid is the same idea as the mid-segment of the triangle. It's just a segment that connects the midpoints of the legs. So if I have my trapezoid, then the segment here where these two are congruent and the segment here where these two are congruent, because it's the midpoint, it connects it on the leg side. And again, the mid-segment is here with the base, just like it is in the triangle. And our last definition is going to be of the kite, and then we're going to move into our properties. The kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. Okay, what that means is when I have Mr. Kite, looks something like this, because you know when you have a little kite, it flies. All right, so I have a little kite. When it's talking about it has two pairs of consecutive sides that are congruent. This is a consecutive side, and this is a consecutive side. The angle between the consecutive sides is going to have a property as well, but it's the bottom half and the top half are my two pairs of consecutive sides. It's not the sides. Okay, it's the top and the bottom, which we'll figure out, we'll know the properties of that in just a moment. All right, so we're going to start with our theorems, and our new rules says Theorem 814. If a trapezoid is isosceles, then each pair of base angles is correct, congruent. Just like isosceles triangles, my base angles become congruent because this is a base down here, so those two base angles are congruent. This is a base up here, so these two base angles are congruent. So angle A is congruent with angle D, and angle B is congruent with angle C. If a trapezoid has a pair of congruent base angles, then now he's isosceles. That's just my converse. So this right here is just my converse. It's just saying now that if I have a pair of base angles that are congruent, then I've got to be an isosceles trapezoid because it forces, when the base angles are congruent, and I want you to think about this, when my base angles are congruent, it's going to force the two sides to be congruent. Because now if these base angles are congruent, these have to be congruent B and C. Why? Because of my parallel lines. Think back to when I had parallel lines back in Unit 3. If these two lines are parallel, then on the side right here I've got consecutive interior angles and I only have 180 degrees to play with. Here I'm going to have another pair of consecutive interior angles with 180 degrees to play with. So if A and D are congruent, then it's going to force B and C to be congruent, which then forces the sides to be the same length. So it just forces it all to happen. That would be like the proof. Theorem 816 says, a trapezoid is isosceles if and only if the diagonals are congruent. It's because my sides are now congruent, my base angles are now congruent, so now my diagonals become congruent if it is isosceles, not a regular trapezoid, only an isosceles trapezoid. So they do not bisect at all. It's just that they are congruent in length. So then, if and only if, the whole thing is congruent to the whole thing. There's nothing in between. There's no bisecting, no anything, the just two lengths are congruent. That's it. You know, if I have a mid-segment, I'm going to have a mid-segment theorem. And the mid-segment theorem is exactly like the mid-segment theorem from before. It just adds on the fact I have two bases. With a triangle, if you recall back in Unit, I believe, 6 with my similar polygons with the triangle, that my mid-segment equaled 1/2 of my base, whatever my base was, that's that parallel side. So now with my isosceles trapezoid, I didn't spell that right, I don't think, but that's okay. Isosceles trapezoid, it's still 1/2 of my base, but now I've got two bases, so I have to add them together. So it's the same idea as the other mid-segment, it just adds on the fact that now I've got two bases, I have to account for two bases, where with the triangle I only had one base. So MN is parallel to AD, and MM is parallel to CD because he's the mid-segment. Then it's 1/2 of base 1 plus base 2. It doesn't matter who you call base 1 and who you call base 2, it just matters that they're the two bases of the trapezoid. All right, we got two other little theorems, and then we're just going to practice. We need to talk about our kite, because we haven't talked about our kite yet. So, with our kite, a quadrilateral is a kite, then its diagonals are perpendicular, which means I've got the right triangle. Now remember, when I've got the right triangle show up, then I have my friends show up and they come to the party, the Pythagoras and my SOHCAHTOANS. So my trig functions and my Pythagorean theorem probably will get used to find a diagonal or find a side depending on what information is given. If I'm given an angle, I would use SOHCAHTOA to try to find another side or whatever. So remember, whenever this shows up, it shows up here, the rhombus and the square. So when those diagonals are perpendicular in those three things, SOHCAHTOA or Pythagorean theorem can be used. So here it just says CA is perpendicular to BD. Just remember, when I have a right triangle, and I'm going to have it there as well. All right, 819 just says, now, I have these two consecutive sides that are congruent, that when my quadrilateral is a kite, yeah, then my angles, the hinge, I call it the hinge between the top and the bottom, is also congruent. So here, angle A is congruent to angle C. It's the hinge between the two opposites of a consecutive congruent sides. But with that as well, B and D are not congruent. It is only the hinge between the consecutive sides. It is not the top and the bottom. It's only the hinge between. So now, we want to find out, we're going to do some examples. We want to find out that four figures, these four polygons, have both pairs of opposite sides congruent. Number 6, what is the most specific name for this quadrilateral? So first of all, what's going on in this quadrilateral? We know this quadrilateral has four congruent sides. We also know that there's no angle measures. So I can't just say, oh, he looks like a square. He must be a square. He has no angle measure. So do we know it's a 90-degree angle? No. So therefore, the only one by definition, the only polygon that has four congruent sides that we don't know the angle, the angle measure for is my rhombus. And last but not least, is the information in the diagram to show that this quadrilateral is an isosceles trapezoid. Well, the first thing I need to figure out is, one, what's the measure of angle J? So the measure of angle J is going to be 180 minus 102. Why? Because we don't know that he's parallel. I mean, I assume he's parallel, so maybe I can't even go there. So maybe I just need to go ahead and start with the 360 because I don't even know he's parallel. So 360 so then now I know that x is going to be 78 by that. So I guess I need to start with the whole quadrilateral because I'm not even sure. So I'm going to start with him being just a quadrilateral, so he's going to be 78 degrees. Now I know that angle F is congruent to angle G. I know now that angle G is congruent to angle H, which then forces FJ to be congruent to GH. So yes, by theorem 815, he's an isosceles trapezoid. Thank you. Have a great day.